Today we are going to continue the last session, formulas of trigonometry. As you remember, we had discussed formulas of associated angles and compound angles, and now we will proceed to the next chapter, that is transformation. If you recall, the formulas which we did yesterday were sin A plus B and sin A minus B. So sin A plus B is sin A cos B plus cos A sin B. Sin A minus B is sin A cos B minus cos A sin B. Now, if you add these two formulas, you will get 2 sin A cos B is equal to sin A plus B plus sin A minus B. If you subtract these two formulas, you will get 2 cos A sin B is equal to sin A plus B minus sin A minus B. So this becomes the first formula of transformation, and this becomes the second formula of transformation. Now, we had also done these two formulas cos A minus B is cos A cos B plus sin A sin B. Cos A plus B is cos A cos B minus sin A sin B. If you add these two formulas, you will get this becomes number 3. If you subtract these two formulas, you will get 2 sin A sin B is cos A minus B minus cos A plus B. This becomes number 4. So these are the first 4 formulas of transformation. Now, in the formulas 1, 2 and 3, in the formulas 1, 2 and 3, if you put angle A equal to C plus D by 2, angle B equal to C minus D by 2. If you put these in formulas 1, 2 and 3, you will get sin C plus sin D, 2 sin C plus D by 2, cos C minus D by 2. Then Sin c minus sin d is 2 cos c plus d by 2 sin c minus d by 2. Cos c plus cos d is 2 cos c plus d by 2 cos c minus d by 2. So these are formula number 5, 6 and 7 of transformation. In formula number 4, if you put A equal to C plus D by 2, B equal to D minus C by 2. In formula number 4, if you put A equal to C plus D by 2, B equal to D minus C by 2, you will get cos C minus cos D is equal to 2 sin C plus D by 2 into sin D minus C by 2. So this becomes formula number 8 of transformation, and this completes the formulas of transformation. So there are total 8 formulas. Incidentally, why are these formulas called transformation formulas? You will notice that they are converting a sum or a difference into a product, or they are converting a product into a sum or a difference. That is why these formulas are called transformation formulas. Now we move on to the next set of formulas, that is called multiple angles. Multiple angles. Now you know that sin A plus B is sin A cos B plus cos A sin B. In this formula, if you put B equal to A, then sin 2A is equal to 2 sin A cos A. This is the first formula of multiple angles. You could also write 2 sin A cos A like this. If you write 2 sin A cos A like this, 2 sin A cos A by sin square A plus cos square A, then you will find that it simplifies to, after dividing numerator and denominator by cos square A, it simplifies to 2 tan A by 1 plus tan square A. So this is formula number 2 of multiple angles. You know that cos A plus B cos A cos B minus sin A sin B. In this formula, if you put B equal to A, you will get cos 2A is equal to cos square A minus sin square A. This is the third formula of this chapter. If you write cos square A as 1 minus 2 sin square A, it will become, if you write cos square A as 1 minus sin square A, it will become 1 minus 2 sin square A, that is number 4. And if you write sin square A as 1 minus cos square A, then it will become 2 cos square A minus 1, that is formula number 5. if you divide cos square a minus sin square a by cos square a plus sin square a, and if you divide every numerator and denominator term by cos square a, you will get 1 plus tan square a, 1 minus tan square a by 1 plus tan square a. This is formula number 6. If b is equal to 2a, then sin 3a is sin a cos 2a plus cos a sin 2a. If you put b equal to 2a, then sin 3a is sin a cos 2a plus cos a sin 2a. Now, if you write sin 2a as 2 sin a cos a, then this expression becomes 2 sin a cos square a. So 2 sin a cos square a, if you write it as 1 minus sin square a, the end result is 3 sin a minus 4 sin cube a. This is formula number 7. So I repeat again, you write sin 3a in this manner, write cos 2a as 1 minus 2 sin square a, sin 2a as 2 sin a cos a, convert cos square a to 1 minus sin square a, and this is the formula number 7. Similarly, you can derive this formula for cos 3a. Cos 3a is cos a cos 2a minus sin a sin 2a. So cos 2a is 2 cos square a minus 1, sin 2a is 2 sin a cos a. So this becomes formula number 8. Cos 3a is 4 cos cube a minus 3 cos a. So these are the first 8 formulas of this chapter. Now in this chapter you will learn 2 new ratios, sin 18 degree and cos 36 degree. You are already aware of sin 30, cos 60, etc. Now we will learn sin 18 degree and cos 36 degree. How do you find sin 18 degree? You begin by saying let theta equal to 18 degree. So 5 theta equal to 90. So 2 theta is 90 minus 3 theta. So sin 2 theta is cos 3 theta. Cos 3 theta can be written as 4 cos cube theta minus 3 cos theta, and sin theta can be written as 2 sin theta cos theta. Now if you take cos theta common from both sides, you will get 2 sin theta is 4 cos square theta minus 3. If you write cos square theta as 1 minus sin square theta, you will get a quadratic like this. This quadratic can only be solved by using the Sridharacharya's formula, the quadratic formula. And after using the quadratic formula, you will get root 5 minus 1 by 4. So this brings us to the result, sine 18 degree is root 5 minus 1 by 4. Now similarly, suppose I want to find cos 36, so it is 1 minus 2 sine square 18. Now you have just seen how to find sine 18. You apply the value of sine 18. So this will become 1 minus 2 into 6 minus 2 root 5 by 16. So after simplification you will get 2 plus 2 root 5 by 8, which means that the answer will be root 5 plus 1 by 4. So this is cos 36. So sine 18 degree and cos 36 degree, these two standard angles will be added to your already known standard angles like sine 30, cos 60, etc. Now let's discuss about the multiple angle formulas of tan. You know that tan A plus B is tan A plus tan B by 1 minus tan A tan B. In this formula, you now put B equal to A. So you will get 2 tan A by 1 minus tan square A. So this is the multiple angle formula for tan 2A. Now if you put B equal to 2A, then you will get tan 3A is tan A plus tan 2A by 1 minus tan A into tan 2A. Now tan 2A is 2 tan A by 1 minus tan square A. So after you put all these values and take an LCM, you will get 3 tan A minus tan cube A by 1 minus 3 tan square A. So this is the formula for tan 3A. So this completes all the formulas of multiple angles. Now we will move on to the next chapter and the formulas in that chapter. This is properties of triangles. So we will now discuss the formulas of properties of triangles. suppose you have a triangle ABC and the altitudes of this triangle are AD and BE. The side opposite angle A, we will refer to it as small a side opposite angle B will be referred to as small b, and side opposite angle C will be referred to as small c. Now you can easily see from this diagram that sine B is AD by C. Sine B is AD divided by C, or you may say AD is equal to C sine B. Sine C is AD by B. AD is equal to B sine C. So B by sine B is equal to C by sine C. Now, if you draw the circumcircle of this triangle, and let O be the circumcenter. So you draw the circumcircle of this triangle and join BO and produce it to meet the circumference at E, and then you join EC. Now you know from angle properties of class 10, you know that these two angles are equal, and you also know that angle in a semicircle is 90. So this angle is 90. So in triangle ABC, you can say that sine A is equal to small a divided by diameter. Let's say radius is capital R, so diameter will be 2r. Now if you combine the result which we obtained over here with the result which we obtained just now, then you will get the first formula of this chapter: A by sine A equal to B by sine B equal to C by sine C equal to 2r. So this formula is known as sine rule, and this is the first formula of this chapter. Coming back to the original diagram, let's say we have this diagram again. Now you can see in this diagram that AB square, AD square is AB square minus BD square. Now we can write AD as B sine C and AB as C and BD as A minus CD. So CD will be B cos C. So C square minus A minus B cos C whole square. So B square sine square C is C square minus A minus B cos C whole square. Now if you square both sides, if you simplify both sides, then you will get B square plus A square minus C square is equal to 2AB cos C. So that gives us cos C equal to B square plus A square minus C square by 2AB. So this formula is known as cosine rule. So we had sine rule and now this one is cosine rule. This is the second formula of this chapter, it is known as cosine rule. Now, in this triangle, you know that area is half base into height. So base, if you take it as BC, and height if you take it as AD, so the area is half BC into AD. So BC you take it as A, and AD will be equal to C sine B. So the area of the triangle will be half AC into sine B. This is the formula to find the area of a triangle. Now, in this formula of area, if you replace sine B with B by 2R, then you will get another expression for area, that is ABC by 4R. So, area of a triangle, you can use this formula, half AC sine B. You can also use ABC by 4R. So depending on the situation, you can use this or this. So these are the second and third and fourth formulas of this chapter. This was the second, this is third, this is fourth formula of this chapter. Now cos C, we were able to get a result. We can manipulate the result as follows. You know that cos 2 theta is 2 cos square theta minus 1. So cos C will be 2 cos square C by 2 minus 1. Now let us equate this with B square plus A square minus C square by 2AB. Let us equate this with this. So we will get 2 cos square C by 2 is equal to A plus B whole square minus C square by 2AB. So this becomes A plus B plus C by into A plus B minus C by 2AB. So cos C is equal to A plus B plus C into A plus B minus C by 4AB. You remember in mensuration of class 9 and 10, you have studied something called semi-perimeter of a triangle. So semi-perimeter is S. So if you use S, then you will get cos square C by 2 is S into S minus C by AB. So we now get cos C by 2 is equal to root over S into S minus C by AB. So this is the fifth formula of this chapter. Cos C by 2 is root over S into S minus C divided by AB. To obtain this formula, we manipulated cos C like this. Suppose if we had manipulated cos C differently, suppose if we had written cos C as 1 minus 2 sine square C by 2, then 1 minus 2 sine square C by 2 is B square plus A square minus C square by 2AB. So 2 sine square C by 2 is C square minus B minus A whole square by 2AB. So that is C plus A minus B into C minus B plus A by 2AB. Once again, it will be C minus A plus B into C minus b plus a by 2ab. Once again you take the help of semi-perimeter, so it is coming root over s minus a into s minus b divide this is sine c by 2, and this 2 and this 2 will get adjusted in the semi-perimeter. So this brings us to the next formula, that is sine c by 2, and the answer is s minus a into s minus b by ab. This is the next formula, sine c by 2. Once you know sine c by 2 and cos c by 2, you can say that the area of the triangle is equal to half AB into 2 sine c by 2 cos c by 2. Sine c by 2, this is the formula, and cos c by 2, this is the formula. So you can hardly call this a new formula. You may remember this is the very well known Heron's formula. So today you have seen, using properties of triangles, how we have been able to derive the very well known formula known as the Heron's formula. Now, in properties of triangles, we have had a few formulas in which we have seen circumradius. Now let us see what about in radius. You know that in circle is a circle which touches all the sides of a triangle. So let us say the in center of the triangle is I. So you can say that area of AIB plus area of AIC plus area of BIC is equal to the total area of the triangle. So half R into C plus half R into B plus half R into A is equal to the area. So if you take half R common, then half R into A plus B plus C is equal to area. So R will be equal to area by semi-perimeter. So whenever you are trying to find out the in radius of a triangle, you can use this formula, area divided by semi-perimeter. So this is a very useful formula to find the in radius. I would like to say that there are two special triangles where you can find circumradius in radius by some other method. What is that? Suppose if you have an equilateral triangle, so you have seen that the formula for circumradius is ABC by 4 into area. So if it is an equilateral triangle, then the answer will be A by root 3. In fact, it's better you commit this to memory because it's a much simpler result. And in radius of equilateral triangle, you know that it is area by semi-perimeter. So area by semi-perimeter. So the answer is coming A by 2 root 3. So circumradius is A by root 3, in radius is A by 2 root 3. Although we have formulas for circumradius and in radius, but when only equilateral triangle is being discussed, it is better to use these formulas. They give the result very directly. So suppose you have a triangle ABC and you have drawn an in circle. This is a right angle triangle, mind you. Now the in radius is small r. So we can say that if you call this point as P and this point as Q, you can say that AP is equal to small c minus small r and CQ is small a minus small r. So by tangent properties of class 10, these two will both be the same, these two will both be the same, and these two will add up to give the hypotenuse, which is B. So if you are talking only about a right angle triangle, it is better to use in radius is A plus C minus B by 2. Regarding circumradius, you know angle in a semicircle is a right angle. Since this is a right angle, circumradius will be half the hypotenuse. So the answer will be simply B by 2. So whenever you are doing a sum pertaining to right angle triangle, use these results directly. Equilateral triangle, use these results directly. So this completes the formulas of properties of triangles. The last topic is trigonometric equations, and we will discuss the formulas of trigonometric equations now. Suppose you know that sine theta is half. You are aware that there are many solutions for this, there are infinite solutions. However, the solution which is smallest in magnitude is called the principal solution. So the solution which is smallest in magnitude is sine pi by 6, right? And this pi by 6 is called the principal value of theta. Now in general, if you have sine theta equal to sine alpha, alpha is the principal value, the rule is that the principal value should necessarily lie between minus pi by 2 to plus pi by 2. Now if you bring sine alpha to the left, you will get 2 cos theta plus alpha by 2, sine theta minus alpha by 2 is 0. Now if cos theta plus alpha by 2 is 0, it means that theta plus alpha by 2 is a multiple of pi, because you know that cos of any multiple theta is a multiple, odd multiple of pi by 2, because you know that cos of odd multiple of pi by 2 is always 0. So this gives theta equal to 2n plus 1 into pi minus alpha. So let us call this as number 1. On the other hand, you can have this quantity to be 0. That means sine theta minus alpha by 2 is 0. So theta minus alpha by 2 is n pi. You know that sine of any multiple of pi is 0. So this gives theta equal to 2n pi plus alpha. So when you took one case, you got theta is 2n plus 1 into pi minus alpha. The other case, you got theta is 2n pi plus alpha. If you combine both of them, then you get the first formula of this chapter, that is theta equal to n pi plus minus 1 to the power n into alpha. So when n is odd, it becomes this. When n is even, it becomes this. So this is the first formula of this chapter, that is trigonometric equations. Now In all cases of sine theta equal to sine alpha, you will use this formula, but there is only one case where you will use another direct result. If you are told that sine theta is 1, then you will use theta is equal to 4n plus 1 into pi by 2. Any multiple of 4 plus 1 into pi by 2, the sine is always 1. So only when sine theta is 1 you will use this. In all other cases you will use this. Now let's discuss cos theta equal to cos alpha. You know that cos goes from maximum value of cos 0, which is 1, to minimum value of cos pi, which is minus 1. So the principal value alpha should lie between 0 to pi. Now if cos theta equal to cos alpha, then as we always do, bring cos alpha to the left and do transformation. So after the transformation you will get 2 sine theta plus alpha by 2, sine alpha minus theta by 2. Now if sine theta plus alpha by 2 is 0, then theta plus alpha by 2 is a multiple of pi. So theta is 2n pi minus alpha. On the other hand, if sine alpha minus theta by 2 is 0, we can also say that sine theta minus alpha by 2 is 0. So theta minus alpha by 2 becomes equal to pi. So theta becomes 2n pi plus alpha. You have two results. If you want to combine them into one, then this will be the result. That is, theta is 2n pi plus minus alpha. As you have seen in the case of sine, here also there is one special case, that is when cos theta is equal to 0, then theta will be odd multiple of pi by 2. Okay? Only when cos theta is 0, then you can consider theta is odd multiple of pi by 2. Now let us discuss tan theta equal to tan alpha. You know that just like sine, tan goes from maximum of tan goes from minus infinity at minus pi by 2 to plus infinity at pi by 2. So this is the principal value range for tan. Convert both the tan to sine and cos. And then you cross multiply. And bring all the terms to one side. You will get sine theta minus alpha is 0. As you know by now, the sine of any multiple of pi is 0. So theta minus alpha is n pi. So theta is n pi plus alpha. So the general solution for tan theta equal to tan alpha is theta equal to n pi plus alpha. This completes the formulas for trigonometric equations, and in fact with this we also come to an end of this particular topic, that is trigonometry formulas.